So in this video, I'm going to be covering the solutions to the limiting reagent problems. All right. Even though it says limiting reagent, this worksheet also covers the process of calculating theoretical yield. All right, which is the maximum amount of a product that you could make. All right. So the first one we actually did in class, but again, when you have when you have more than one starting material, like you do in this problem here, the first thing that you want to do is to calculate the moles of each of those problems. All right, and when you do that, you're going to get a certain number of moles, and remember, you can't just look at the one that you have less of. All right, because depending on the mole ratios that are required, you might have something where you actually have more moles of something be the thing that actually runs out first. So the way to determine that is to divide each by the coefficients in the balanced reaction, and then to compare those numbers. All right, the one of those numbers that is the smaller number would be the one that runs out first. All right, so in the first one, we determined that carbon would be the limiting reagent, and because of that, we use the number of moles of carbon to figure out how many of our product we could make. All right, so we start a crossbar with this number moles of carbon. We've got a 2-to-1 ratio of carbon to tin, and that number comes from the balanced reaction, which I can show here. So that number comes from just taking these coefficients here. All right, for every 2 moles of carbon, we could get 1 mole of tin. All right, and then to convert moles of tin into grams of tin, we use this last relationship right here. All right, so that would give us the theoretical yield, and again, that is the maximum amount of tin that you could make from this reaction. All right, generally when you do a reaction, you get less than the theoretical yield. All right, so in the next problem, all right, so one thing that's different about this problem is that they give the amount of zinc here in grams. Oh, I'm sorry, both of these are actually in grams. My apologies. So we're going to convert each of these into moles. All right, we divide this number of moles by its coefficient, which is 2. This one by its coefficient, which is 1. And then we compare those two numbers. Since this number right here, these are very close, but this number right here is still slightly smaller. So we are going to take that number of moles, which is the limiting reagent, and calculate a theoretical yield, all right, which would be this number right here. Okay, the next problem. Okay, in this problem right here, this is one where we actually have one which is given in grams and the other is given in moles. All right, so for the one that's given in grams, all right, the zinc chloride, we have to convert that to moles. All right, we're going to compare that to the number of moles of potassium hydroxide, but that number is already given for you. So I can compare this number to this number. Again, this number right here comes straight from the problem. All right, whereas the number of moles of zinc chloride, I had to calculate from grams. All right, but we end up doing the same thing. We take the number of moles of this, we divide it by its coefficient. We take the number of moles of this, we divide it by its coefficient. And then you take those and you divide by the coefficients, and this one is less, so therefore that is the limiting reagent. All right, so taking that number, starting it with the crossbar with that number of moles, we end up getting this right here, and that gives us this as our theoretical yield of potassium chloride. All right, so in this problem right here, we've got grams of both of our reagents. All right, again, I've written in the numbers here that are going to be relevant. I could write in a molar mass for this, but I can read in the problem that I'm not going to need that particular molar mass, so that's why I did not write that down. All right, so these are the two moles, amounts of moles that we have from our two different reactants. All right, taking each and dividing it by the coefficient and the balanced reaction, we can determine that this right here would be the limiting reagent. So starting a crossbar with that, and first step you're going to do is a mole-to-mole ratio between product and reactant. So we've got the 2 moles of water being able to be produced from the 1 mole of this material right here. And then we convert that to grams of water, and we end up getting 1.94 grams of water. Okay, so hopefully that makes sense, and that's it for this video.